Great. So I've got with me here a touch-based game controller, right? You can see you can basically do all sorts of things with it. It's basically a game controller that is touch-based, controlled by an Azoteq semiconductor proximity chip, the IQS333, interfacing with a PIC microcontroller that you see there. That is a PIC4550 using a wooden overlay, right? So this is the wooden overlay as a touch surface, right? So the system is basically powered by 3 AAA batteries, making it portable and efficient, and can be used for all sort of touch-based applications. Great. So the key component in this combo here is obviously the controller, the IQS333, which is a capacitive touch controller capable of detecting touch and proximity through the wooden overlay, right? So it uses advanced algorithm, and because of this, it can filter the noise and adjust environmental conditions. As you can see, it's able to work with a wooden overlay. Then we've got the PIC microcontroller, right? So that is a PIC4550, which is an 8-bit processor, and it acts here basically as the guy that is controlling everything that's going on in this setup here. So it receives data from the IQS333 here via the I2C interface of the PIC microcontroller, and it executes the action based on the touch input of the user, right? Then we've got the wooden overlay. Now, these act as a touch surface, right? So it's the touch surface here. And the IQS333 here, the capacitive touch controller, is able to sense the touch effectively, even though we are using a non-conductive material like wood, as you can see, okay? Making it versatile for various type of application. So the power source, as we've said earlier, it's just the AAA batteries, so it's very much portable, and you can just imagine what kind of application you can use with this combo here. As you can see here, I've got a rotary switch here, right? And I've got my 7-segment. As I bring my finger, we basically updating the encoding through the 7-segment display there. And equally so, if I press a button, you can see there is a number that is being registered, 78. Now, these have been already calibrated through a process, right? And from here, you can also see it's like a slider switch here that we've got, and you can have actions being implemented based on whatever number you've got on each of the position. Okay, so this is just one example of what you can do here. Now, how does it work basically? So the controller here, the IQS333, basically operate by measuring changes in capacitance, okay, and caused by the finger that you are basically touching here, okay? So basically the IQS333 detects the input and it processes it, okay? Then it sends the data via I2C communication protocol to the PIC microcontroller, okay? Then the PIC microcontroller will then read these data here, interpret the input, and perform corresponding actions. Like you can see here, we're now displaying the data onto the 7-segment display. So this is what the processor, the controller, the PIC microcontroller is basically doing. But it's taking the data coming from the IQS333. Now the wooden overlay here basically showcases the IQS333 ability to sense through non-conductive material, right? So I can remove the wooden overlay here and put another plastic overlay. We're still going to basically get the same thing. All we have to do is to basically just recalibrate the system and it will operate. And this is particularly useful for application needing a seamless aesthetic design. Now let's talk about the advantage of this setup here, this combo here. First of all, it's very robust, right? It's a very robust sensing, and because it can detect through the wood, right? You don't get many applications that are able to perform this seamlessly, as you can see here, okay? And the second advantage, it's low power, right? This can basically be left like this, it will go into sleep mode until you bring your finger again and it will detect, right? So it's very much low power. Then one last advantage is obviously the versatility, the ability for it to work in different material, and that means you can use it for all sort of applications. Okay, now in summary here, basically the IQS333 together with the PIC18F4550, and they create a robust low power touch interface, right? And the wooden overlay or the wooden interface here basically demonstrate how capacitive sensing can be seamlessly integrated into everyday material, especially when you make use of the Azoteq IQS333. Now, this combination offer a wide range of possibility for innovative and user-friendly design. So that's what I wanted to share with you. So if you want to basically integrate this onto your system, let me know. I will provide to you any material you want for the support, whether it's for the IQS333, the Azoteq semiconductor, or a sample code to basically have the combination with the PIC microcontroller interface. Thank you for watching, and if you find this useful, please make sure you give it a thumbs up and subscribe to CMTEQ channel. Until next time, cheers.